that process and water cannot go up. So you just transfer the thing to the next group, right? And that process, in general, it should be pretty efficient but on the other hand, what happens in a startup is that in a startup, you typically have innovation happening on multiple fronts, right? So to build that single chip PC, we had to increase the complexity of the process. We had to bring in chips that were designed on one process, working with another process together. So there was all kinds of additional engineering that was needed. So about half a dozen new technologies came together, and when you have something like that, your risk goes up exponentially. So we go through the development process. And it's basically a very efficient way of developing, but it really works more in bigger companies, because in bigger companies, most of the new products are evolutionary versus revolutionary. So can somebody give me an example of evolutionary products? Products that evolve from existing products, and then you have additional products. Yeah, PCs are one, but think of some kind of
calculators they develop into big calculation machines and big tablets.
Tablets, yeah. Okay, give me non-computer.
Facebook.
Yeah, Facebook is continuously evolving, but is adding just one feature after the other. But okay, any non-computer, non-software examples? Automobile cars is another good one, because if you look at it, all cars are continuously, they're adding different lights, different seating, different everything. So it's basically developing by enhancing a core model that you have. And then every now and then you have something revolutionary going on. So when the hybrid car came along, that was revolutionary. When the electric car came along, like Tesla, right? That was revolutionary. So in one sense, Toyota took 2 steps to become electric. So they went from gas to hybrid, and ultimately they'll go to electric, right? And then they might even go to solar power. They might even go to
Hydrogen power.
Yeah, hydrogen power, exactly. So those are revolutionary because everything changes when you go to these, a major change. But the majority of engineering that happens inside a company is evolutionary. So they're kind of evolving from an existing product line. They're coming up with additional models, different price points, different features, different luxury brand, different economy brand, 2-seater, 4-seater, 6-seater, 8-seater, 12-seater. It just goes on and on and on. And when you're going evolutionary, then the waterfall model is very good. Because you pretty much know your customer. You know that people generally have 2 seats, so 4-seater is fine. But you go to, you'll find that because the government single-child policy in China, 80% of all families in China are single families, so they're 3 or 5. Their grandparents are there, right? So basically, there's a segment that is involved that if you bring your cost down or size down, or you can make it faster, for a 3-seater or a 5-seater, then you're going to get advantage in the marketplace versus a 4-seater. So that's how marketing thinks. Marketing thinks by something called segmenting. What's segmenting a market?
Dividing the customers, different types of customers.
By right? You segment the customers by different parameters. And what kind of parameters?
Maybe locality. Maybe locality. Maybe
Roads that you have,
profession.
or roads that you have, kind of weather that you have, you know. So there are so many things in the ecosystem that you can segment it with. And the whole, what determines the success when segmenting is the strategy? What determines the success of
Targeting
one
the
company?
target
Target
segment
market.
that is correct for you.
Segment is satisfied with the product.
Segment is satisfied with the product so that you. But what if you segment a very small market and you win 100% of that market? Is that
How do you
okay?
project and place your product in that? How do you project and place your product in that particular segment you're domain that you have?
So, would you say that Rolls-Royce that only targets 0.1001% of the market, is it a successful company? Right? And General Motors that services, or Toyota that services everything, is successful. So you can be successful with many kinds of segmenting strategies. Okay, so what about unsuccessful companies that are there in the high-end segment? Why are they unsuccessful? There are so many high-end car companies that have disappeared. So why do they fail?
In that particular segment they are targeting, they have other competitors who have a better customer plan.
Maybe they stick to one particular idea and they are not changing.
They really did not understand the customer needs for that segment. So actually, you know, when you have a marketing-driven innovation, you know, it's all based on segmentation. It's all based on superior understanding of how customers are. It's all based on your engineers coming up with the perfect product for that segment. And so the reason you can fail is because you either target a very small segment, or you have competition that does a better job than you, or you know, you end up having, you know, basically a market segment that is not a very profitable segment. So if you look at Intel, where I worked, our strategy was to continuously target the high end of the market, which is the highest performance PC and the highest performance everything, charge a lot of money, and then make so many chips that, and then bring the price down, that everybody has to upgrade to this chip, and I make money when it's a premium segment PC, then I make money when it becomes a mass product, and then I basically obsolete it out, but then I come up with the next chip that will go ahead. So Intel had two strategies. One was called high performance, and one was called high integration. One was focused on cost reduction, one that's focused on high performance. And that's generally a good strategy when you can figure out one or two axes on which you are developing your product. Then it's easy to tell the marketing guys, okay, you are the high performance group. Just figure out how to make the fastest, best. You are the high integration group. Do that. And then if you're a competitor to Intel, what do you do? So right now, huge competition for Intel came from not their traditional competitors like NEC and AMD and everybody, but who became Intel's largest competitor? Qualcomm is in communication chips. They are not in the computing or the microprocessor.
ARM.
Exactly. So how did ARM become Intel's biggest competitor? When Intel had, you know, about $30 billion in the market, in revenue, in actual money sitting there. They've got the biggest fab capacity, they've got the best manufacturing process to make these chips. They've got every customer in the world. Their salespeople are talking to all the customers that make computers. And yet, in 5 years, ARM has become one of the most successful microprocessor manufacturers. In 5 years. How did that happen? So, they were not building high integration, right? Because Intel could build the best integration. Intel could build the highest performance because they've got the best semiconductor manufacturing plants and R&D engineers for all the process. So, what access did ARM come out with that gave them this big competitive advantage? Cost Intel good with high integration.
Did they combine performance and integration?
We partnered with some computer manufacturing companies like Dell, for example, which only used their chips in a certain level of PCs, a certain line of PCs they used. So that is how.
No, Intel watches like a hawk. Yeah, Intel if it sees even one, if Dell even tries to use an AMD chip for one computer or one PC, Intel will just attack. In fact, Intel would be so vicious that they would actually see that the manager who's designing that PC gets fired. They even get you out of the company because Dell is buying multi-billion dollars worth of PC microprocessors from Intel, and if Intel just goes and increases the price for Dell compared to somebody else, then Dell could lose lots and lots of money. So,
the size of the chip?
size, no?
It would be like they were focusing on targeting the segment over which the Intel was not that much powerful.
Yes, you're getting there. That's a good point.
But the interest was not in that segment. They were targeting them at that main segment.
Okay, so what was that thing?
Mobiles and tablets.
Smartphones and tablets. So, in smartphones and tablets, what was the access that was needed? What parameter was needed?
Compact
Compact size.
Compact. Their chips are the smallest. What is the biggest problem? One of the biggest problems in a smartphone and tablet? Battery. Exactly, battery life. So power consumption. You don't want a hot phone next to your heart or in your pocket. You don't want a phone that gets really hot. So basically, they attacked low power, and then the other thing. See, Intel also was focused on low power, but Intel's low power technology never became the best. So ARM decided that they would have the best low power computing technology. So yes, in power, ARM became the best. They kind of specialized and became the best. But they did something else. What did they do? So what happens with using Intel is since 90% of the PCs are built with Intel, you really cannot tell the difference between an Intel PC and a Taiwan PC and an HP PC and an IBM. You just cannot tell the difference. They're basically the same. They have different colors and all that, or different shapes and sizes, but PC is a PC, right? And does Apple want to build something that looks like an IBM or something? Apple wants to be unique, right? So they want to be unique everywhere, and if they just start using ARM's or another microprocessor manufacturer's chip, what happens? Then everybody is cloned. Everybody will build a smartphone or a tablet which looks exactly like an Apple in terms of performance and everything else. So what ARM did was, not only did they design the chip, but then they provided the entire design of that chip to a manufacturer. They provided all the design tools for customizing that chip to people like Apple and to everybody who wanted to get access to, to build an ARM processor. So basically, what ended up happening was that they leveraged the low power, so it was a viable product to build. And then they provided a business benefit to these big companies that wanted to be unique in the marketplace. So they provided the ability to customize in a proprietary way, but with a common core. So ARM could keep developing ARM 1, ARM 2, ARM 3, now then ARM 6, ARM 7, whatever it is. The common core, ARM could keep improving, and people like Apple kept on customizing, will take that, customize it, so you cannot build something that's identical to a tablet, because this one has got maybe a little bit more security, it's got some more additional features like a GPS built in, whatever it is that Apple would have built it, like a fingerprint detector or whatever it is, and that's how Apple gets the differentiation, and that's their competitive advantage, and they kind of encourage ARM to keep developing higher and higher performance, because ultimately we'll have something that's competing with the best, which is Intel, high integration. Those are the things that ARM would work on. So ARM, so you basically have distributed development. ARM specializes in low power, high performance, high integration, and all